In this video, we're going to look at how to solve rational function inequalities. For our example, we're going to be solving for values of x that makes a function 2x divided by x squared minus 4 greater than or equal to 0. When we solve equations or inequations, it's always good practice to observe the restriction on the function. Since we've got x squared minus 4 on the denominator and we can't have the denominator equaling 0, this means that we cannot have x being equal to 2 or negative 2. Our next step is to get rid of the denominator. To do this, we're going to multiply both sides by the square of the denominator, which is the square of x squared minus 4. And you might ask, why do we have to multiply by the square of the denominator and not just x squared minus 4? And the reason is because we want to make sure that we're multiplying both sides by a positive term so that we don't have to worry about reversing the inequality sign as we would if we were to multiply by a negative number. And this now allows us to get rid of the denominator, and we can get rid of 1x squared minus 4 factor on the left top. And on the right hand side, 0 times x squared minus 4 will just be 0. So that will disappear. So that our next line becomes 2x times x squared minus 4 is greater than or equal to 0. We now factorize x squared minus 4. So we have 2x times x plus 2 times x minus 2 is greater than or equal to 0. To solve this inequality, we're going to be sketching the polynomial graph. So let's consider the function f of x is equal to 2x times x plus 2 times x minus 2. This polynomial has zeros at x is equal to minus 2, 0, and 2. So we're going to mark this on the number line. Then we're going to consider the leading term of f of x. To get the leading term, we're going to multiply the x term from each factor together. So 2x times x, that's going to give us a leading term of 2x cubed. So this means that as x approaches infinity, f of x will be approaching the function 2x cubed, which will be approaching positive infinity. So our graph will be heading this way. As x approaches negative infinity, our f of x, which approaches 2x cubed, will be approaching negative infinity. So it's going to be heading this way. Then we connect all this information with the zeros, and we're going to join them up for the graph of f of x. Now, since we're solving for f of x is greater than or equal to 0, we're going to be interested in sections of the graph that is above the x-axis. So this is going to be between negative 2 and 0, and also for x is greater than or equal to 2. But since we've got the restriction where x cannot equal to plus 2 or minus 2, this means that we're going to have to exclude these values of x. So our solution becomes x is greater than 2, or x is greater than negative 2 but less than or equal to 0. And to make sense of all of this, here's the graph of the function y is equal to 2x divided by x squared minus 4. Since we're solving for 2x over x squared minus 4 is greater than or equal to 0, we're essentially looking for the section of the graph that is above the x-axis. So it's going to be this highlighted section here. And these sections of the graph corresponds to the values of x where x is less than or equal to 0 but greater than minus 2, and this section is where x is greater than 2. Thank you everyone for watching the video. I hope you guys enjoyed that. For more videos on this topic or other topics, please have a look at our channel. If you haven't already, don't forget to subscribe. We release videos weekly on various maths topics, and we would love to see you all in the next one. Bye for now.